Okay, so today we'll be taking notes on law of cosines. Yesterday you learned law of sines, which works for non-right triangles. Law of cosines is also useful for non-right triangles, and you see a definite pattern here. It looks like we have three different formulas, but the pattern is exactly the same in each one. At the beginning we have a side squared equals the other two sides squared and added together, and then minus 2bc, so that's the same two letters as we have here, b and c, so minus 2bc, and then cosine of a, capital A is the angle across from this starting side that we used, and we see that pattern all the way through. So if this is little b on this side, then we're going to use angle b at the end. And then the other two sides are a and c, so we have a squared plus c squared, and then a and c in the second two positions. And then same thing with the third one, little c here, so big C is the angle that we're going to use. And then the other two sides are a and b, so a and b go here as well. So we have the same pattern for all three of these. So you really, if you memorize just one of those, then you know the other two are exactly the same. Okay, and so you might be wondering why we have law of sines and law of cosines. So we have different situations where we use each one. Yesterday you learned law of sines, and that is sine A over A equals sine B over B equals sine C over C. We use law of sines in these three situations when we have two angles on a side, two sides on an angle, or two angles on the side in between them. So those are situations where we want to use law of sines. And for law of cosines, we would use that when we have two sides and the angle in between them, and all three sides. And so we'll do a couple examples of those. And then don't forget that anytime you have a right triangle, you can always go back to SOHCAHTOA. SOHCAHTOA will always work, but for right triangles only. And so law of sines and law of cosines are what we use for non-right triangles. So you can add that to your notes if you want, for non-right triangles. Okay, so let's take a look at example 1 on that page. In this case, we're given two sides and the angle in between them, so that is SAS. And as we saw here in our notes, when we have SAS, that's when we want to use law of cosines. And so since we have this angle, we want to start with the side across from it. So our equation is going to be b squared, since we know the angle across from it. So if we have b squared here, we're going to end with the cosine of 100. And then the other pieces of the equation, since we used b squared here, then that's going to be a squared plus c squared minus 2ac times the cosine of 100. And so now we'll just fill in the numbers for all those. So b, we don't know. A is 7, so 7 squared, because that's a because it's across from angle A. And then c is across from angle C, so lowercase c would be 5. And then minus 2 times those same two numbers, 7 and 5. And then the cosine of 100. And so then if we type all that into the calculator, make sure you're in degree mode, and then type in 7 squared plus 5 squared minus 2 times 5 times 7 times the cosine of 100. And that is b squared equals about 86.1554. And then b is going to be the square root of that. So if you just take the square root of that last answer that you got, you get b equals 9.28 approximately. So we have side B now is 9.28, or 9.3 if you round to the tenths place. And now we can also find the missing angles. So it doesn't matter which angle we find next. If we want to find angle A, we can now use law of sines to do that. And so we can say the sine of A over the side across from it equals the sine of 100 over the side across from it. And then when we cross multiply, we get 9.28 sine of A equals 7 times the sine of 100. Sine of A equals 7 sine of 100 over 9.28. And if you take the inverse sine of both sides, inverse sine of sine A equals inverse sine of 7 sine 100 over 9.28. The sine and the inverse sine cancel. We get angle A is equal to the inverse sine of 7 sine 100 divided by 9.28. I'm going to use the previous answer on the calculator for that, so I have actually more accuracy than just the 2 decimal places. And we get 47.9611 degrees. So we'd say angle A is about 48 degrees. Or to the nearest tenth, let's say that would be 47. Well, actually, it would still be 48.0 if we round to the tenths place. And if that's 48 degrees, then we can subtract from 180 to get angle C. So 180 minus 100 minus 48 is about 32 degrees. So now we know all 3 sides and all 3 angles of that triangle. We used law of cosines to find the first missing side, and then we used law of sines to find the missing angles. Any questions? Okay, so the next example, we are given all 3 sides of this triangle. So that's SSS. We know all 3. SSS. And so that's another scenario where we want to use law of cosines. And as it says in the directions here, we always want to find the measure of the largest angle first. The largest angle is across from the largest side. So find the largest angle first when you have SSS. Okay, and so the largest angle is going to be across from the largest side. The largest side is 12, so across from that is angle C. And so since we're going to put angle C here in the cosine formula, then what's our law of cosines formula going to start with? What letter? Lowercase c squared, because if we have uppercase c here, we're always going to start with lowercase c here. So those are always the same letter. So that means it's going to be a squared and b squared here, and 2ab times the cosine of c. And so if we fill in the numbers then for that, that's going to be C squared is 12 squared equals A squared plus B squared minus 2 times A times B times the cosine of angle C. Now this time our unknown is an angle, so we have to solve for angle C. And the algebra is a little bit tricky here, so we have to be really careful on the rules of algebra. We don't want to make a mistake of dividing by all this stuff or subtracting all this stuff. That would not work. We have to do it in algebraic steps. And so what we can do first is subtract 10.5 squared and subtract 6.3 squared. And so we're going to have 12 squared minus 10.5 squared minus 6.3 squared equals negative 2 times 10.5 times 6.3 cosine of C. And then what would the next algebraic step be? How do we get cosine C by itself? We will eventually, but how do I get rid of the numbers that are in front of that, Wesley?
We divide the whole equation by negative 2 times 20.
Right, so we're going to have to divide this stuff out. Now you could multiply these in your calculator first. It doesn't matter if you do that first or if you divide by all three of them, but we just need to make sure that this entire quantity is going to get divided by negative 2 times 10.5 times 6.3. So we want to make sure that's all in the denominator. So we have to be really careful with parentheses on the calculator. So now all of these cancel. So we have cosine of C equals whatever this number is. And so I'll show you on the calculator where we have to put the parentheses. So it's going to look like this. We're going to have parentheses, so make sure you start with parentheses, 12 squared minus 10.5 squared minus, oops, I have an extra parenthesis in there. Okay. 12 squared, I don't need this parenthesis either. Here, I'm just going to start over. So 12 squared minus 10.5 squared minus 6.3 squared. Okay, close the parenthesis for the top. And then divided by, start a parenthesis for the bottom. Negative 2 times 10.5 times 6.3, and then close the parenthesis for the bottom. So it's really important that you put the entire top in a set of parentheses and the entire bottom in a set of parentheses. Otherwise, that's not going to work out right. So that answer turned out to be 0.044898. 0.044898. Okay. That is the cosine of C. And so now, as Wesley suggested earlier, or I think it was Wesley, maybe it was Pablo, we need to take the inverse cosine of both sides. So if we take the inverse cosine of cosine C, then we're going to take the inverse cosine of 0.044898, and those cancel, so we get C equals the inverse cosine of that previous answer that we got is 87.4 degrees. Are you getting the same result? 87.4 degrees. Okay, so now we know angle C. This is 87.4 degrees. Okay, Now we're ready to find the other two angles, and we can find the other two angles, or find either of the other two angles by using law of sines. Okay, so now we can say, if let's say we wanted to find angle B, we can say sine of angle B over 6.3 equals the sine of 87.4 over 12. And so then we have 12 sine B equals 6.3 sine of 87.4, or sine B equals 6.3 sine of 87.4 divided by 12. And then B would be the inverse sine of that. So I get 31.6 degrees for angle B. And now I can subtract those from 180. 180 minus 31.6 minus 87.4 is 61 degrees for angle A. Any questions on those? So now we know all three sides and all three angles of that triangle. Yes.
When do you know how to use the law of cosine and the law of sine?
So you can use the notes we took at the very beginning to tell how to start the problem. So if you know two sides and the angle in between them, you're going to use law of cosines. If you know all three sides, you're going to use law of cosines. In the other three situations, you're going to use law of sines first. Even for the law of cosines problems, you only have to use law of cosines once, and then you use law of sines to get the other missing pieces. Okay?
Yeah, but where would you start like the count off, like for SAS and SSA? So
It's whatever information you're given. So in this first example, we were given the 5 and the 7 and the angle that's immediately in between them. So that's SAS. In this problem, we were given all three sides, so that's SSS. Okay? All right, good question. Okay, so let's go to the next page. And so we want to draw just any general triangle. We don't have to try to make it look accurate. Just any general triangle, and label it A, B, C. And side B is 23. Side C is 18. Angle A is 173 degrees. So obviously my drawing is not to scale because 173 is an obtuse angle. And I didn't draw it that way, but that's okay. So this is an SAS case. So SAS, we're going to use law of cosines. Okay? In problem 4, all three sides are given, so that's SSS. Okay? So I'd like you to go ahead and try these. If you're watching the video, pause your video and work out both of these problems, and then press play when you're ready to see the solutions. Okay, so for problem 3, since we know angle A, that's the only angle we know, the 173 is going to have to be at the end. So we're going to end with cosine of 173, which means we need to start with the side across from it, which we'll call that little a. So a squared equals b squared plus c squared minus 2bc cosine of a, which is 173. And so then if we fill in the pieces that we do know, we know b is 23, we know c is 18, okay. Now to do this, I want you to watch the calculator work, because when I was coming around helping students, I realized not everybody really knows the functionality of your calculator. So if everyone could stop what you're doing and watch up here, please. When I find A, well, let's go ahead and evaluate that left side. So if I have 23 squared plus 18 squared minus 2 times 23 times 18 cosine of 173, that gives me an answer of 1674.828. Okay, that's a squared, so if I want to know a, I take the square root of that. Okay, now here's where, on the calculator, I realized that not everyone understands that you can actually grab that value. So if I do second square root, okay, instead of retyping that, just if you have a TI-84, you can scroll up and highlight that value and press enter, and it automatically fills it in for you. So I did that just by using these arrows, the up and down arrows, to grab that value. So you don't have to retype, just go up and grab the value and press enter, and it gives you much more accurate results than if you're rounding at every step. So yeah, you can also use the answer button, which is down at the bottom, except by scrolling up and grabbing a number allows you to use a number that you have higher up on your screen. So you could go up, 3 or 4 steps previously and grab any number that you can see on your screen and use that in a problem. So that turned out to be 40.9. So A is 40.9. Okay. Now we can use law of sines to find either of the other angles. So if I wanted to find angle B, for example, sine of B over the side across from it equals the sine of 173 over the side across from it. And so then we would get B is equal to the inverse sine of 23 sine 173 over 40.9. And that is about 3.9 degrees. And so if B is 3.9 degrees, then now we can subtract from 180. 180 minus 3.9 minus 173 is 3.1. So angle C is 3.1 degrees. And now we know all 3 angles and all 3 sides. For problem number 4, this is SSS, so this is where we have to be really careful with the algebra, and we always want to find the largest angle first. Since 50.3 is the largest side, we have to find angle C first. Okay, so we would do C squared equals A squared plus B squared minus 2AB cosine of C. So we'll fill in what we know. 50.3 squared equals 35 squared plus 42 squared minus 2 times 35 times 42 cosine of our unknown angle C. And here's where the algebra, you have to be really careful here with the parentheses on your calculator and with the algebra. So we're going to have 50.3 squared minus 35 squared minus 42 squared equals negative 2 times 35 times 42 cosine C. And then we're going to divide both sides by negative 2 and 35 and 42. Negative 2 and 35 and 42. And that's where you have to have the parentheses for the entire top and the entire bottom when you put that in the calculator. So I have cosine C is equal to so I have to start with parentheses and put in the top 50.3 squared minus 35 squared minus 42 squared. Close the parentheses for the top. And now divided by, start parentheses for the bottom. And I'm going to have negative 2 times 35 times 42 in the denominator. And so notice the entire top is in parentheses, the entire bottom is in parentheses. And so when I enter, I get 0.15609. And then I have to take the inverse cosine of both sides. So C is going to be the inverse cosine of 0.15609, but I don't have to type that in because remember, I can grab that on the calculator. So if I do inverse cosine, I can go up and grab that value and press enter, and it tells me that that's an 81-degree angle. So angle C is about 81 degrees. Okay? Now we only have to use law of cosines once per problem. So now I can, once I've done the law of cosines once, now I can use law of sines to find the other missing parts. And so if I wanted to find angle A, I could say sine of A over the side across from it equals the sine of 81 over the side across from it. And so then that gives me sine A equals 35 sine 81 over 50.3, and so then take the inverse sine of both sides. And that gives me, those cancel, so A equals inverse sine of 35 sine 81 divided by 50.3, and that is 43.4 degrees. And so now that I have 43.4, I know two angles I can subtract from 180 to get the third one. 180 minus 81 minus 43.4 is 55.6. So now I have all three angles and all three sides. Any questions so far? Okay, we'll stop there. So this video will be on the website if you need to rewatch it, any of those examples. when you're trying out the homework assignment.